Hi again, Precalc students. This would be the rest of lesson 11.1, limits in motion, the tangent problem. In this next page of notes, we'll look at some example problems where we're asked to estimate slopes using a graph. And again, estimating slope is like estimating a derivative, because the derivative is the slope at a point. So in exercises 7 to 10, use the graph to estimate the slope of the tangent line if it exists to the graph at the given point. So taking a look at this, number 7, what is the slope of the tangent line at x equals 0? Let me grab a marker here. Well, what's the slope at 0? Here's 0. If I go up to the curve at 0, this would be the point at which we're trying to find the slope. So if I were to draw a tangent line as best I can, that tangent line, it just touches at that one spot. What would be the slope? Oh, it looks like it's about a slope of 1. That would be my best estimate. Okay, that would be perfect, but that looks like it's a slope of 1. Looks like it goes up 1, right 1, up 1, right 1, up 1, right 1. Number 8, what's the slope of the tangent at 1? Well, here's 1. Find the curve. There's the output at 1. What would be the slope of a tangent line at that point? Well, I don't know, it looks like we're going maybe down 1, right 1-ish. So if I had to estimate, I'd say that that would be a slope of -1. Okay, that's my derivative, that's my slope at a point. Number 9, what's the slope at 2? Well, here's 2, go up to the curve at 2, and this is the point. What's the slope right here? Well, this is a tricky one. So what we got going on here is, as we're approaching from the left, we have this nice solid slope because it's a linear function, right? This looks like a piecewise function. I have a line here, then I have a different line to the right. Well, because these two slopes are like hard, fast slopes, and they don't match, there is no slope at that point, okay? So anytime that you have a corner, let me erase that so we can see it better. So at 2, my curve, my graph has a corner. That means that there is no slope. A corner does not have a slope. Okay, if it's a hard corner, or if it's a cusp, which is like a curvy corner, we do not have a slope. So there is no derivative there. I would say it's undefined. Okay, no slope because there's a corner. Number 10, what's the slope at 4? Well, at 4, I have this point right here, but coming from the left, I'm somewhere different. So again, with this piecewise function, in this case, like the curves, like the slopes don't match from left and right, but the curve, like the graph doesn't even come together. There's a hole there. So once again, I'd say that my slope is undefined. It doesn't exist at that particular point. So again, where it says if it exists, that's the key. We will not have a slope or a derivative at a corner, at a cusp, or at a point of discontinuity. A curve, a graph has to be continuous in order to be differentiable, which means be able to find a derivative at that point, okay? So that's undefined there as well. Sorry, I'll spell that right. Now, for exercise 11 to 14, it says graph the function in a square viewing window using radian mode, blah, blah, blah. And then use the slope of the graph to determine whether f prime of 2 is positive, negative, or 0. Okay, so positive, negative, 0. So what I'm going to do is I have these all graphed in Desmos. I'm going to drag Desmos into the screen so we can all see it. Okay, hopefully you got that all right. So let me make this bigger. Can I do that? There we go. So red is x cosine x, which is the very first example. A lot of stuff going on here. I'm going to just turn off some of these graphs so we can look at it one at a time. So x cosine x is the first graph, and we're looking for the f prime of 2. Well, that means the slope at 2. So just looking at this curve, I would say that the f prime of 2 is negative something because our graph is tending downwards from left to right. So the slope at this point right there would be negative. That's all I have to say for an answer there. It says positive, negative, or 0. Well, this one's heading downwards. It's decreasing. That means my slope is 0. If I turn on the next one, turn off the red. So here's this blue curve is x plus 1 sine of x. What's going on at 2? Well, when x is 2, my point is right here. It looks like my slope is negative there as well because we're heading downwards. There's this little peak, but it's to the left of 2. And I think we're heading downwards as we travel past 2. So negative slope once again at that value. Third curve, x cubed minus 3x squared plus 2. What's going on at 2? Well, here looks like at 2, I have the bottom of a valley. I have a relative minimum at that point. You click on it, it says 2, -2. So if I have a relative minimum like this, this means that the slope is 0. Like if you were to zoom in close enough, you'd see that the closer and closer I get, a nice smooth curve tends to turn into a straight line the closer we get to it. What would be the slope of this nice straight horizontal line? Well, that would be 0. So anytime you have a slope of 0, there's a chance for being at a maximum or a minimum point. So this would be a relative minimum down here at the bottom of a valley. But the slope is definitely 0 at that point. And the final example, x times cosine of x squared. What's going on at 2? At 2, it looks like my slope, my graph is increasing, so my slope would be positive at that point. So hopefully that makes sense. Again, just graph the functions and take a look at that point. When x equals 2, where are we and what's the slope? Okay, the slope is either positive or it's negative or it's 0 from those examples. All right, the final page then involves finding derivatives if they exist of a function at a point. So we did some examples like this already. That's the derivative at a point. A is the x value given to you here. Do the same kind of work that we did earlier. One thing to note, number 27, because this is an absolute value function, that's going to have a corner and probably going to have a corner at -2 and not have a derivative there, just FYI. So what I want to do is I'm going to look at a couple of these examples real quick. So 29, 30, and 31, what I did is I wrote out in that completed problems those. I'll walk you through the explanations for each. So for all three of these problems, it says find the derivative of f. So the first one, number 29, f of x equals 2 minus 3x. Well, to find the derivative of f, just the derivative of a function, I'm looking for a brand new function, and that brand new function will describe the slope of the original function at any value of x. So 2 minus 3x, that's my function I start with. Now real quick, 2 minus 3x is a linear function with a slope of -3, right? So if I have a new function that tells me the slope, it should probably just be -3 because that's the slope. Okay, just FYI, you can see the answer down here in the bottom right corner. It's -3. How do we get there? Well, to find the derivative of a function, f prime of x is equal to the limit of the difference quotient. The f of x plus h, so there's an x now instead of an a, because I don't have a specific value at which I'm finding the derivative. I'm finding a new function in terms of x. The f of x plus h minus the f of x all over h. So I work through that process now. The f of x plus h means take x plus h and plug it in for x in this function. 2 minus 3 times x plus h. Minus the f of x, which is plugging x into the function, so 2 minus 3x. Do some algebra to clean it up. Distribute the -3, we get -3x minus 3h. Distribute the -1, we get -2 plus 3x. Combine some like terms. 2 minus 2 is 0. -3x plus 3x is 0. -3h over h is all that's left. H's cancel. That equals -3. The limit as h approaches 0 is -3. Remember we said that was going to be the slope because it was a linear function with a slope of -3. Duh, but not really duh, okay? But that's how I would use all this calculus stuff to come up with -3. Hey, that's the slope of this function. Number 30, I have a parabola, 2 minus 3x squared. Same process. F prime of x equals the limit of the difference quotient. So the f of x plus h is me plugging in x plus h in for x in this function. So 2 minus 3 times x plus h squared. There it is. Minus the f of x, 2 minus 3x squared. There it is. Do some algebra. I did a bunch of this in my head. Again, if you got to write out x plus h and squared by hand, that's fine. But you should just be able to square the first term, get x squared. Multiply the two together, that's 2xh, or double it, and then square the second term, that's h squared. Then distribute the -3 to all three of those terms. That's what I got here. I got -3x squared minus 6xh minus 3h squared. The 2 is still there. It didn't go anywhere. I distribute the -1 here to get -2 plus 3x squared. That's why those terms are what they are. Combine like terms. 2 minus 2 is 0. -3x squared plus 3x squared is 0. All I'm left with is -6xh minus 3h squared. That's what you see over here. It's all over h. Next step would be to divide both these terms by that h. So that cancels this h and cancels one of these two h's, leaving me with -6xh minus 3h. And again, we're finding the limit of this expression as h approaches 0. At this point, it's okay to now plug in 0 for h, because it's not going to make me divide by 0. Negative 3 times 0 is 0. It's not there anymore. So this turns into negative 6x, a brand new function that describes the slope of this function at any point of x. Neat, huh? Final one. 31, 3x squared plus 2x minus 1. Let's find the derivative. F prime of x equals. The limit as h approaches 0 of the f of x plus h. X plus h gets plugged in for that x and that x. Minus the f of x, the original function. Do a bunch of algebra. I'll let you kind of walk through this. 3x squared plus 6xh plus 3h squared. That's that piece. Plus 2x plus 2h. That's that piece. Minus 1. Minus 3x squared minus 2x plus 1. There they are. Combine the like terms. 3x squared minus 3x squared is gone. 2x minus 2x, gone. Negative 1 plus 1, gone. 6xh plus 3h squared plus 2h is what we got left. Divide them all by the h. You get 6x plus 3h plus 2. Find the limit of that as h approaches 0. Plug in 0 for h. 0 times 3 is 0. That leaves me with 6x plus 2. A brand new function that describes the slope of this curve at any point of x. So that's again, very fast run through of how you find derivatives of functions using the limit of the difference quotient. Again, if you don't like this, you don't get the algebra, maybe don't take calculus. Just saying. If you're all right with it and you follow it, calculus will be a breeze, no sweat. Okay?